Hello, calculus fans. Let's take the function f of xy equals xy over x squared plus y squared, and let's ask if the limit of this function exists as xy approaches 0, 0. Let's approach along the x-axis where y is equal to 0. Then f of x 0 is equal to 0. So we'll say that as we approach along the x-axis, f approaches 0. Now let's approach along the y-axis. So we'll put in x equals 0. Now we'll get f of 0, y equals 0. So the function approaches 0 along the y-axis. So we've gotten identical limits by approaching along the coordinate axes. This does not prove that the limit is 0. Because remember, we can approach in any way we like, along any path and in any manner. So just approaching along these two particular paths, getting the same answer, doesn't prove anything. Maybe there's some other path we could approach along where we would get a different limit. In fact, if we try to approach along a different line, we will get a different limit. Let's approach along the line y equals x. So now, as long as x is not equal to 0, and we won't really care what happens at x equals 0, we'll get f of x, x, so we replaced y with x. We get x times x over x squared plus x squared. That all works out to a half. So now, f of xy will approach 1/2 as xy approaches 0, 0, specifically along the line y equals x. So here's a picture of what we're dealing with. Approaching along a couple of lines, specifically the coordinate axes, gives us limits of 0. Approaching along this diagonal line gives us a limit of 1/2. Now we've obtained different limits along different paths, so the limit does not exist. Okay, that's all for now.